Hello, in this video I want to go a bit deeper into how to make field coverage patterns. You already see some fields here on the screen. This is actually my village, Budel, in the south of the Netherlands. There's a lot of agriculture around, with many small patches that can be processed. So let's pick one of these patches and create a coverage operation. I'll click here to start, trace round the boundary and double click to finish. When defined, it will zoom into scope. Now that we have defined this field, we can give it a description, set the row distance and set the minimum turning radius in meters. And with that done, we can generate a path. Okay, let's show the result. Here's what happens. The line up to the red dot is taken as the first swath. All the following swaths are created parallel to it. So this first swath continues forward. You can edit the map and choose a different starting point. Notice that when I move the starting point, the Generate Path button disappears because the definition has changed. Click it again and a new path is generated, parallel to the new first line. This works for all convex fields for every start position. So let's do it again for this point and you will see that the result is very similar. For non-convex fields, the field may not be able to be covered in one go, meaning all the swaths parallel to each other. That means we need a strategy, and I created one that is implemented, but it's still in test. So with non-convex fields you have like a dent in the circumference. Basically the directly neighboring points to that point can be connected with a line which is outside the field. So that makes it a non-convex field. So let's generate a path for our first non-convex field. So in this case, although it's a non-convex field, all the swaths are still parallel to each other. So that will be different if we choose a different start point. Let's do that here. Yes. So that looks a bit different. You see actually different areas being constructed here. So the big field is divided into several pieces, here too. So the first piece is filled with swaths parallel to the upper left line, because that is the line left of the start point. That is what we defined. And actually the area is the largest area that can be covered with this swath direction. That is the orange area. That leaves a second area, the purple area. The two areas have a common side, and this side is the starting line for the second area. So the swaths filling the purple area are parallel to this line. So this also goes if we change the point to the next one here. We still have a very similar situation. So let's generate it. And we see the result here, also two areas, only different ones. Also the swaths in the first area parallel to the first line, leading to the start point. And the second area, we can see the line between the purple and orange part. So that line parallel to that line, the second area, the purple area, will be filled. If you start here, you do it in one go, you have still 300 meters, 200 meters less. Okay, let's see how this turns out for a different field. This is a nice field with a cutout, so let's see how that effectively because this strategy may not always work. Collapse and expand. 6, 2, save, generate. So this is point, everything's parallel to this line where you can do everything in one go. Question is, can you do it like this? So maybe we use this point. It is not done in one turn. You can see here kind of division, so this patch is done first and this patch is done second. Okay, cool. We have more challenging fields and this looks nice. Okay. So here it chooses this line, parallel on this line starts, because yeah, this is the starting point and it's divided in this first swath, then it starts here, which is kind of in the middle of the field, which is not very nice and practical. But you see the strategy, but when it finishes here, it needs to go to this patch, so you have to go across it and then do that one. Let's see how this turns out. This is actually quite acceptable. Here's the road, so we can start here and then this is the first patch. When it finishes, and this is outside the oh no, it ends here. It starts there. There it goes here. Yeah, quite acceptable. Okay. This uses 4 patches. It starts here, this parallel line goes here. When it is finished, it goes to this area. When it's finished, it goes to this area. When that is finished, it can finish this. The benefit here, I have an optimization strategy, yeah? So you might think it's very obvious that if this swath is done, then the next one is this. Well, it is obvious because the distance is the least, but actually it calculates it. It calculates an optimal order of execution, and of course the penalty is the distance. So if the distance is small, get a small penalty. So it is obvious that if this one is done, then the second one is this one and the third, but that is not always the cases. So sometimes you see some irregularities, but here it turns out great that after I finish this one, that it starts here and then continues here, so the extra distance is small here also. So there is new functionality, download KML, and you can load it in any program that has KML loading. Let's make a so here it is, trajectory. So here are the separate swaths, and it's ordered in the execution order 68, 69, 70, etc. If you exclude the swath, you just keep the field. What's also nice is that you can make other fields in Google Earth would look very similar as you do in Fleetly. Only you don't double click to stop it. Here you have to close the form, and then you have a path. So let's delete this one. So we only have this, the export, and Fleetly. Let's import it. How cool is that? Generate a path with that. Okay. This can be done in one go, and then we finish off there. Looks pretty good to me. So to recap, the direction of the first swath is determined by the start point and start line. Concave fields can be processed all with parallel swaths, and some non-concave fields require a strategy which divides the field into patches. The patches are processed sequentially, and the first patch is as large as possible, and then the second, etc. And KML export and import for fields allows the use of external programs.